Complex numbers. Part of complex numbers are imaginary. Okay, so let's talk about definitions. What's the opposite? If I say imaginary, what's the opposite of imaginary? Real. Okay, so what's a real number versus an imaginary number? Well, real numbers are numbers you can put in the calculator. Anything I can put in a calculator. Anything I can add together, subtract, multiply, divide, right? Anything I can do there, if I can do that, that's real. Okay, so it's easy to tell if something's real or not because you can use your calculator. Okay, so anything you can't use a calculator for is imaginary, and that's what we're going to talk about today. Why are these imaginary? Why are they not real? You're going to find out all about that today. Okay, so let's start out with something that's real. These three guys I can put in my calculator and get an answer. Okay, you guys probably know the answer. What's the square root of 16? 4. So why is 4?
Because it multiplies itself.
There you go, right? If I were to multiply 16, change 16 to 4 times 4, right? Any number times itself is a square root. So that's why 4 is a square root, right? What's the square root of 81? 9, because 9 times 9, right? 9 times 9 makes 81, right? So what's the square root of 100? 10, right? We know the rules. That's why the square root of 16 is 4, 81 is 9, 100 is 10, right? So let's go to these guys. What's the square root of negative 16? So negative 4, so let's see. Has to be the same number, right? So negative 4 times negative 4 still makes positive 16, right? So it's not going to be negative 4. It's not going to be positive 4. It can't be a negative and a positive. I had a student tell me, how about negative 4 and positive 4? Well, that doesn't work because it's not the same number. Negative 4 means you owe me $4. Positive 4 means here's $4. That's different, right? They're not the same. Okay? So what is the square root of negative 16? We don't know, right? So if we don't know, let's go to our calculator. That's what we usually do, right? We always say, if I don't know the answer, let me go to my calculator. So I go to my calculator and I put the square root of 16 and it says undefined. Undefined means I don't know. It's like, I don't know. Error sometimes it says. Because it's not a real number. There's not a real number that if I multiply by itself will make negative 16. So if there's not a real number that makes that, we have to create one. It's called an imaginary number. Because you're going to see these. This chapter, you're going to see square roots with negative underneath. So what we're doing is not creating, but we're showing something that's not real. So how do we show something that's not real? We got to have another way, right? So this is how you do it. We're going to say the negative 1, the square root of negative 1 is not real because I can't get that answer, right? So we're going to call that I. I is a number, but it's imaginary, right? I is imaginary. So this is what I'm going to do to solve it. Instead of negative 16, what I'm going to do is I'm going to split it up a little bit. So instead of negative 16, I'm going to say negative 1 times 16. Is that still negative 16? Mm-hmm. So I didn't change anything, right? I didn't change the number. The reason I did it that way is because then I can write it like this. The square root of negative 1 times the square root of 16. What's the square root of 16? We know that. 4, right? But that's not what we're done, right? We also have the square root of negative 1. And what is the square root of negative 1? I. So what is the square root of negative 16 equal to? 4i. So when do we have an I? When there's a negative inside the square root, because that's going to be imaginary every time. 81. Instead of negative 81, let's write negative 1 times 81. Still negative 81. So I have negative 1 times negative, or times positive 81. The square root of 81 is 9, just like we said earlier. The square root of negative 1 is I. So what is the square root of negative 81? 9i. So what's the square root of negative 100? 10i, yeah, 10i. Okay, for the same reason, for the same exact reason. Okay? All right. That is when we have imaginary situation, when our calculator says, nope, that number doesn't exist. Okay? Well, it does exist, it just doesn't exist in the real numbers. It exists in the imaginary. Okay? All right, so let's do some practice here. What's the square root of negative 25? 5i. Good. 5i, right? Because it's same reason, right? Negative 1 times 25, square root of negative 1 times the square root of 25, 5i. Square root of negative 15. Well, is 15 on my list of perfect squares? No. So how do I do it? This is how you do it. We're going to do it the same way we just did the last one. Separate them, right? Except I'm going to leave 15 in the square root because it doesn't have, it's not a perfect square. The square root of negative 1 is I. So it's going to be I times the square root of 15. Okay, we're just going to leave it inside the square root. Is 31 on my list? No, same thing, right? So it's negative 1 times 31. Same thing. 31 is not on my list. So it's going to be I times the square root of 31. Okay, so that's where I comes from. Where does I come from? Why do we use I? Because we're going to have that. We're going to have negatives in the square root. It's going to happen. Okay, so we have to have a way of dealing with it. So we call it I. Okay? Okay. Now here's the thinking part. Okay, so on the other side, we're looking for a pattern. First thing we're going to do is look for a pattern. Pattern is something that you notice, maybe it repeats itself, right? Something going on here. Okay, so we're going to go slow, but stay with me. Okay, so let's look at the back here. We're going to set up a little pattern here. We're going to look for patterns. Look for a rule. A rule is something that happens every time, or happens maybe every 2 times, 3 times, 4 times, right? Okay? Like in this class, usually we have either a test or a quiz every 2 weeks, right? So every 2 weeks, if you look at the calendar since August, every 2 weeks, every other week, we either have a test or a quiz, right? So you're like, if we don't have one this week, the pattern is we're probably going to have one next week, right? That's kind of how I set up the calendar, okay? So I to the first power, that's just I, right? That's equal to the square root of negative 1, right? We talked about that. We just talked about that. So that's just I. So what I'm going to do is I'm going to highlight my answers just to see if I notice anything. Okay. I squared. What does squared mean? Times itself, right? So I squared is really just I times I, right? Isn't that what that is? That means? What is I equal to? Square root of negative 1, right? So really, this is the square root of negative 1 times the square root of negative 1. Really, that's what it means, right? So what is the square root of negative 1 times the square root of negative 1? I'll give you a hint. I'll give you a hint. So let's do some problems. Let's do some easy ones. What's the square root of 2 times the square root of 2?
Square root of 4.
Square root of 4. What's the square root of 4? 2. Let's try a different one. Square root of 3 times the square root of 3.
9.
Square root of 9, right? Which is 3, right? Let's jump a little higher. Square root of 9 times the square root of 9. 81, which is 9, right? Let me throw a bigger one. 721 times the square root of 721. What do you think the answer is going to be? Nope. Even easier than that. What do you think? Look at the pattern. Is there a pattern going on?
Yeah.
I get 2, 3, 9 as an answer. Where do you see those numbers? Yeah, so what's the answer going to be here? 721. When you're multiplying two numbers with square roots and they're both the same, it's just going to be, they cancel each other out. They cancel each other out. So let's go back to the problem we were just doing. What's the square root of -1 times the square root of -1? -1, right? It's just going to be -1. Whatever that number was, that's all it is. Okay. So I know what I to the first power is, and I know what I to the second power is. What does third power mean?
3 times.
3 times, right? So it means I times I times I. Instead of writing it like that, can I write it like this? Take a look at how I'm going to write it. So are all of these, all of those red boxes, do all of those mean I to the third power?
Yeah.
They do, right? They do. The reason I wrote it like that one, I squared plus times I, is because I already know what each of those guys equals. What is I squared equal? -1, right? Did we just say I squared equals -1? So really, isn't this like -1 times I? Because I squared was -1, we know that, right? And isn't I to the first just equal to I? So what is -1 times I?
1.
No. -1 I, or negative I, right? Okay. So I to the third power is just -1I, or negative I. I to the fourth. What's a way I can write I to the fourth using things that I know already?
I squared times I squared.
I squared times I squared, I3 times I1, any of those will work. I'm going to use I squared and I squared because what's the answer to I squared? -1, right? And what's the answer to I squared? Another -1. What's -1 times -1?
1.
+1. I like I squared and I to the fourth because look at their answers. -1 and +1. Those are nice numbers. I and negative I, not so nice. Okay. Let's go to the fifth. How can I rewrite I to the fifth using things I know? I to the third, I to the second, I to the fourth, I to the first. Any of those will work, right? So let's see. Let's go I to the third, I to the second. What is I to the third equal to? Negative I or -1I, right? Negative I or -1I. So really this is negative I. And what is I squared equal to? -1. So what is -1I times -1 equal to? 1I, right? A negative times a negative makes a positive 1I. Didn't I already get that answer? That was my first answer, right? So I'm going to color it the same color as the first answer. I6. How could I rewrite I6? I to the third, I3, I3, right? I2, I4. Any of those will work. I like using I2s and I4s because they have -1 and +1. So I'm going to use, could you use I3 and I3? Yes, you could. but I'm going to use I to the 4 and I squared. Because I to the 4 is positive 1. I2, negative 1. What's positive 1 times negative 1? And I've gotten that answer before too. What do you think I7 is going to be? Let's prove it. Let's prove it. We think it's going to be negative 1i, or negative I. So let's prove it. I7. I7 is I4 and I3. That's pretty much it, right? What is I4 equal to? Positive 1. What is I3 equal to? Negative I. What's 1 times negative I? Negative I, right? You guys were right. What do we think I8's going to be? Positive 1, right? Let's prove it. I8 would be I4 and I4. I4 is positive 1. I4 is also positive 1. That's 1. So there looks to be a pattern. What would I9 be? What would I9 be? What's the next one in the pattern? I, right? What would I10 be? Negative 1. I11, negative I, 12, 1. It's a pattern, right? How many times does it repeat? Every 4 times, right? This is what I'm going to do on a test. I'm going to give you one of those. The one I asked last year was this one, I to the 119. There's 2 ways to do it. Make a long old list like that, and guess what? Not one student did that last year. Because there's a pattern, there's a rule, right? So let's figure out what this rule is so that we don't have to make a long list, right? We can do 21, 48, 74, and 119 without having to do that. Okay, so you guys said it repeated. How many times? Every 4 times, right? Just 4 times, right? It repeated every 4 times, right? So my answer is either going to be I, negative 1, negative I, or 1, right? Right? Darian, put the phone away, please. I got my box here. I will take it out. Okay? That's going to be the answer. Only one of those 4. So which one is it going to be? Well, it involves division. And you guys said how many times does it repeat? 4 times. So we're going to divide by 4. The question is, what are we going to divide by 4? The exponent. So let's do the exponents. Let's do the first line, the first 4. What was the first exponent that I had? Exponent. The first one, 1, right? And then the second was 2, 3, and then 4. So let's see when we divide what happens. 4 goes into 0 how many times? Doesn't fit, right? 0. 0 times 4 is 0. What do we call 1? What do we call 1? It's a remainder, right? We called it last chapter, we called it a remainder. So this guy's got a remainder of 1. How about 2? Still goes in 0 times, right? This one has a remainder of 2. Same thing, doesn't fit. This one has a remainder of 3. How about the last one?
1.
What's the remainder? 0. No remainder, right? Okay, so let's go to 5 now. What remainder would 5 have?
1.
What remainder would 6 have?
2.
What remainder would 7 have?
3.
What remainder would 8 have? None, right? 9, 10, 11, 12, 13, 14, 15, 16. So all of the answers that get I have a remainder of what? What power got I as an answer? 1. So if I have a remainder of 1, I is going to be my answer. What if I get a remainder of 2? What if I get a remainder of 3? What if I get a remainder of, can I get a remainder of 4? No, we get a remainder of 0, right? We get positive 1. So what you're going to do is divide the exponent by 4 and see what remainder you get. So let's do 21. Let's test our rule. So 4 goes into 21 5 times. What's the remainder? So by our rule, what answer should this be? How about 48? 1 time, 2 times, no remainder. So if I get no remainder, what answer should I get every time? 1. Okay, let's do 74, and then we'll write down our rule in words. 74 goes in once, goes in 4 times, 4 goes into 34 8 times, remainder of 2. If I get a remainder of 2, I should get negative 1 as my answer, right? So let's write down our rule here. Let's write down our rule. Again, these are my words, not your words, so if your words make more sense to you, write it down differently. But this is how it makes sense to me. The first thing you're going to do is divide the exponent by 4. Divide the exponent by 4. After that, what did we do? After we divided by 4, what was the important part? The remainder, right? Okay. So number 2, if you get a remainder of ... Well, the only remainders that we got, right, were 1, 2, 3, or 0, right? We never got a remainder other than 1, 2, 3, or 0. Yeah. Right? What did we get when we got a remainder of 1? What was our answer every time when we got a remainder of 1? Okay. What did we get if we got a remainder of 2? Negative 1. What did we get if we got a remainder of 3? Negative I. And what did we get if we got 0 remainder? 1. Now I want you to test this hypothesis, test this rule with 119. What should 119 be?
Can we hang up one of these in your classroom?
Yeah, go for it. Yeah, sure. Okay. So it doesn't matter what power they give you, positive or negative. They could give you a negative power. We haven't talked about negative powers, but you could get a negative power. Divide it by 4. What's the remainder going to be? That'll tell you what your answer is going to be. Okay? This question's either the easiest question or the hardest question. It should be the easiest. Like I said, if your directions don't make sense to you, change them so they do make sense to you. So that when you read this, it makes sense to you. Okay? That's what your notes do. Notes help you so that you don't have to remember things. You don't have to memorize things. Okay? All right. Okay. Oh, also, the other thing. When you divide, calculators might not be the best thing because calculators don't do remainders, right? They do decimals. So, yeah. So when you divide, when we're looking for just remainders, by hand. Do it by hand as opposed to do it, because calculators, there's a way to do it with the calculator, but the calculator won't show you remainders, right? It shows you decimals, okay? So yeah, that's the only thing. Okay, let's go to the last example and we'll do that and we'll be done. Okay, so simplify. So picture I is not a variable. I is not an X. It's not an A. It's not a Y. How come it's not a variable? Because we know what it's equal to. Anything you know the answer to, it's not a variable, okay? But we treat it like a variable. So imagine that was X. 3 plus 5X. 2 plus 3X. What would we do if those were X's instead of I's? We combine like terms, right? What would we do first, though? How would I get rid of the parentheses? Yeah, right? Multiply by the missing one that's in the front, right? So we get 3 plus 5i and then plus 2 plus 3i. Now we can combine like terms, right? So when we combine like terms, always do the real numbers first. Real numbers first. So 3 plus 2 is 5. Imaginary always comes second. You don't do imaginary second, you do imaginary, or you don't do imaginary first, always put them second. So if you put 8i plus 5, that would actually be wrong because real has to come first. All right, real always comes first. Okay. B, what do you think I'm going to do for B? Just rewrite it, right? There's a -1 in front. Distribute the -1. Combine real first. -4, there's nothing to combine it with, so it's just -4. Now the i's. 7i minus 5i is positive 2i.
It's not like the polynomials to where you have to have a positive.
No, yeah, no. This is different. Yeah, it's not. This is not factoring. We'll do factoring next lesson, but yeah, today is not factoring where you have to do all the steps like that. Yeah, good question. Yeah, we don't have to do those today. Okay. All right, so do C. Do letter C if you haven't already. Real always comes first. Plus 2. Done. Okay. So even though this is imaginary, we're dealing with imaginary, we've done this before. This part we've done before. Right? We've done distributing and combining like terms. You guys did on the last test. In fact, on the last test, you guys did something like this. Except instead of i's, there were x's or a's, right? Okay. So if there were x's instead of i's, What will we do here? What did you do on the last test? How did we simplify these guys? Started with a B. Box. 2 by 2 box, because it's multiplication. 2 by 2. 3 plus I, 1 plus 2I. Multiply. 3 times 1 is 3. 1 times I is 1I. 2 times 3 is 6I. 2 times 1 is 2I squared. Combine like terms, just like you did on the test. 3 plus 7I plus 2I squared. Here's the only kicker. The only difference between what you did here and what we did last chapter is when you're dealing with i's, you can't finish with I squareds. If your answer has an I squared, you're not simplified. It's not simplified. Okay, so how do we simplify it? Well, first thing we're going to do is rewrite it. Except instead of I squared, what is I squared equal to? We just said that, right? What was I squared equal to? Look to the left in your notes. What is I squared equal to? -1. So just change it to -1. Swap it with -1. Because it's the same thing. So then you multiply and you get -2. Bring everything else down. Combine like terms again. 1 plus 7I. That's the only difference between x's and i's. No I squareds. No I squareds. If you have I squareds in your answer, it's not done. Okay? How would we do E? Distribute first. So I distribute only to the first one, not to both, just to the first one. And then box, 2 by 2 box again. -42 plus 36I, -4 plus 2I. -42 times -4 makes 168. -4 times 36 makes -144I. -42 times 2 makes -84I. 36 times 2 is 72. I times I makes I squared. Combine like terms. 228I. When I combine them, my answer can't have any I squareds. No I squareds. Well, I know that I squared is equal to -1. That's what it says in my notes. So rewrite it. Instead of I squared, -1, because they're equal to each other. Multiply, you get -72. Bring everything else down. 168 minus 72 is, I believe, 96. Minus 228i. Okay. Last one. What does squared mean? The last one, what does squared mean? Multiply by itself. So if it multiplies by itself, how are we going to multiply f? Yeah. How do we multiply? If we're going to multiply itself, how do we multiply it?
-2i.
Negative. There you go. And how do I multiply those two guys? Using a box. Use a box. Finish out. Tell me what you get. I believe it's 48i. Goodness, I believe that's the answer. Yep. So there's the answer. Show me. Show me how you get that. There you go. Okay. All right. All righty. Fill that up. Sure. Yeah, we'll do it right now.